Hello, it's Brian from Odyssey again, and today I want to introduce my newest little design for an educational platform for robotics. This is it right here, and I've been thinking about it for a long time, trying to come up with a good design that is not too pricey and yet is not dead-ended. There's a lot of really cool robots out there you can buy now that are wonderful. Actually, they're great. They're lots of fun. I have a bunch of them myself. I've got old Bobots and various sumo machines that are available at one time. This one I like a lot. This is a very fast. You buy it, you get it out of the box, and it follows the line so fast it's almost impossible to get any better. And then there's robots like this one, and I've got some other pictures on the web I can show you. Dual DC motors. It's an Arduino type machine, and what I don't like about any of them is they're kind of dead-ended. I shouldn't say I don't like it, but it's the disadvantage of them. Let me show you a few more. Here's again as another one that's you can get, which is kind of like the Breadbot chassis. This is that one I just showed you that I have. There's ones that you can get now that are just chassis that you can use your cell phone, your smartphones with, and they're pretty cool. This one's new. I think it's designed by the MIT team. And again, wonderful platform for learning maybe some computer science. I think one of the nice things about this is, if I'm not mistaken, it doesn't actually use any batteries. It runs off the USB all the time, so you don't have to worry about that hassle. Here's another one that's relatively new today. Again, very cool. I'm sure it's wonderful for teaching computer science. It's got a little expansion capacity. You can snap Legos on top of it and build on it. And it's got a whole array of sensors and whatnot. Very cool. I think it's fairly affordable. I don't see the price here, but I bet you it's in the, I don't know, I'm going to guess $50 range or something like that. But all of these are kind of they kind of hit the wall. What I don't like is after you've played with this robot and you've learned some really cool applications in computer science, you say, "Gee, I want to do something cool. Like I want to put a probe into a rocket and launch it and measure the G-force acceleration. Or I want to put it on a helium balloon, or I want to seal it in a PVC pipe and make an underwater robot or whatever." All of these things teach you perhaps the coding how to do that, but they kind of leave you hanging. This guy here would be kind of difficult to shove into the nose of a small model rocket or to stick into a PVC pipe. And things like this one too. I mean, I'm sure it's great, it's wonderful, but I'd be a touch hesitant to stick my smartphone into the water. So all of these, although wonderful, I wanted something that wasn't going to sort of end, whereas you could take it apart, you would find the parts all useful, and you can build onto it, expand it, do whatever you want. So that's why I kind of put together this one. It's a simple chassis. It's just got 2 DC motors. It's got some little encoder things we can use. It's got some sensors on there that actually I'm going to show you how to build. They're real simple to assemble. Ultrasonic, little 3-color LED so we can play with pulse width and digital signaling and whatnot. We can use these for analogs. It's on a breadboard. But once you have this thing, which you can do sumo battles and line following and have it find the brightest light, and we'll use it for all kinds of various data collection and coding and everything else. Yeah, and you've pretty much exhausted what it is you want to do with this chassis. Of course, you could build onto it. You can see there's lots of places you can attach things. You can actually then just pop this chip out, and you can put it in something like, you know, this motherboard here. And what allows you to do here is now you've got a nice, small, robust platform that once again allows for more expansion. You can continue to build it onto here, or you can, for example, let's see if we can go back and find a few of these here. I'm going to go at the beginning. Oh, that's obviously a robot. Here we go. These are robots that were all built by students at Princeton University. And if you see it right there, there's that same motherboard, that same Teensy. Now you can see it from an overview. And, you know, this is, it goes on and on and on. You can continue to expand it, continue to do things with it. Here's another nice view, a different robot. There's several teams using them. They all use the Teensies in this motherboard and built these amazing machines. You can imagine it might have been difficult to have done something with, you know, one of these, and although we could have taken this motherboard off and mounted it on a chassis, but it's just not quite the same thing, and it's still quite a bit larger. So that's my justification for getting something that's kind of in pieces like this, so that we can build, we can change, and we can adapt. The reason I went with this particular chip is it is Arduino compatible, or mostly. It is not an Arduino product, I should stress that, but it does use the same language, and many pieces of code interchange perfectly. And the only thing, one of the main things you have to do is watch out where your pins are. But it's a powerful chip. It's got 10 analog ports on it. It's got a whole bunch of digital ports. It's got communication ports, receivers, and I2C, SPI, pulse width ports that we can use for a variety of different functions. It's got onboard USB. We can power it directly from the USB. We can also power it from an external source. Great chip, and it's small. You know, once we learn how to use this thing, we can then put it into something else and it do basically anything we want to do. So I'm hoping that's kind of an introduction as to why I've chosen this platform and kind of put it together and assembled it in a kit. And I guess the next thing is to actually start putting one together and learning as we go. So I will see you on the next video. Talk to you soon.